Good morning and welcome to MAE 106 Discrete Mathematics with Probability. My name is Richard Kohar and this is lecture 2. And in today's lecture we're going to cover the introduction to logic. Excellent. I see everyone is writing in the chat. That's great. And make sure that you can tell me that you can hear me okay. Okay. So, I talked a little bit about this yesterday, and good morning to everyone. Yep. I'm just seeing it pop up in the chat. That's great. Excellent. So, what I should do is discrete mathematics. So that's the study of discrete objects. So we talked about that yesterday in the sense of like a piano is discrete in its notes, but a violin can play something that's continuous. So, like for instance, instead of me giving you, unfortunately, a definition for discreteness, what I'll give you is some examples. So here are some examples. So here is the real number line. So these are called the reals. And I can have 0 here. I can have 1. And all these numbers in between here exist. So this is an example of these are continuous numbers. And likewise, if I write over here, should just kind of as my divide line. So these are in the continuous, and just here we'll have discrete. So on and so forth. These are called the natural numbers. And these are discrete. So again, just as a contrast between continuous and discrete. But we can also look at things like discrete objects that are not continuous. So we have numbers. We'll have things that we'll see in logic, like propositions. We have propositions, and we'll introduce that later in this class, and actually in this lecture. Okay. So what we can do is we can ask ourselves, what is logic? And just actually taking a poll in the audience, how many of you have studied logic in high school? I'll just wait just a couple of seconds for people to say if they have, or you don't have to participate, but it just kind of gives me an idea if logic is taught in the high schools. Nope, I did. Yes. Okay, good. Okay. Not tomorrow. Okay. So there's a mix. Okay, but don't worry, we're going to go through this. What this is logic. It's the study of the methods and principles used in distinguishing correct from incorrect arguments. So now the question becomes is, what is an argument? And so we have what is an argument then? Well, here is an example of an argument. Okay, nothing is better than eternal happiness. A passing grade is better than nothing. So that little symbol, those three dots, means therefore. Therefore, a passing grade is better than eternal happiness. Okay. And again, you could be like, do you really think that a passing grade will give you eternal happiness, or am I just trying to pass bad logic off to you? So again, we get back to this part of how could we distinguish this argument? I've given you something here from a correct or an incorrect argument. That's not a question, that was more of a where I'm going to be going next in terms of with this lecture. So that's kind of our leading question. So let's look a little bit at what an argument is. And to kind of talk a little bit more about an argument, or what is an argument, I need some more definitions. I know it keep diving into more and more what I gave you a definition, and then I'm expanding that more and giving you another word, and then I have to expand on that more. So I have an argument, and this is an example of one. And arguments are made up of propositions. So arguments are made up or consist of okay. So a proposition is just a sentence that declares or states something. So definition. So it's a meaningful declarative statement that we can declare. Okay, so it's either true or false, but never both. And we will use T for true and F for false. Get that out of the way. So is everyone okay with that? So we have logic. It's the study of methods and principles of distinguishing correct from incorrect arguments. An argument is a collection of propositions, and a proposition is a meaningful declarative statement that's either true or false. And these are, when we describe something with a proposition, we give it either a true or a false. These are called truth values. So some examples of propositions can be like Richard likes math. Napoleon is dead. Ten plus 4 is less than pi. Kingston is in Ontario. So again, these are propositions. Okay. Things that aren't propositions. So those are things like is this on the test? Which is a question. So this is not a proposition. It's a question. Again, it's a question. Again, propositions is something where I can assign a true or false. If you could just give me a question, I can't say true or false. I can answer yes or no, but that's not what a proposition is. Let's see, something like look out. You can already see what sort of things that you can look at. If it's, I have a question mark at the end of this statement. I have an exclamation point at the end of this. If you're writing a question mark or an exclamation point, it's not a proposition. This is what we call, these are exclamatory. And again, it's not a problem. Now, interestingly enough, the truth value of a proposition can depend on the person making the judgment or on the time and circumstances in which that statement's made. So what this is saying is that the truth of a statement could change over time. But we won't really be concerned about something like that. Or their truth values. Okay, so when we're looking at trying to figure out if it's a proposition or not, we don't really care what the value is, if it's true or false. We only care if we can actually, that given a specific point in time, that we can decide. So it's more about decidability. Okay. Something else. Let's go through some of these. What are other things that are not propositions? So let's see, all angles are progals. Okay, again, the reason that this is not a proposition Because this is meaningless. What is a hingle and what is a progal? If we don't know what they are, then we can't decide if this is true or false. So, nope. She enjoys math. This isn't a proposition. And why do you think that this is not a proposition? In the chat, what do you think? Is this a proposition? She enjoys math. Too vague. Who is she? Exactly. So we have this pronoun here. Exactly. It's unclear. Yep. Yeah, everyone's getting it. They nailed it. Who is she? So, and then continuing on with this. So I have, she enjoys math. X plus 7 equals 11. I can already tell you because we're working in a list of things that are not propositions, so you already know that, or inferring it because I'm in my list. This isn't a proposition, but why? With this example, x plus 7 equals 11. Why is it not a proposition? X is unknown. I'm not sure about that one. The answer is a number, and if the number isn't stated, it can't be proven true or false. Well, no, it's not quite that. It's because I still can't decide if this is a proposition, and that's why it's not one. Because X is unknown, sure, but there's also the fact that I have an infinite number of possibilities for this. Because X is not known, I mean in the sense of what kind of number is it? Is it a real number? Is it a natural number? Is it a finite number? 0, 1, 2. We just don't know what kind of number it is. So for instance, if I had a real number in there and I had a natural number, I could then give you something like where x equals 4. That would be a false proposition. Then I would be able to decide it. But again, I don't know what kind of number it is. Okay. So we have things that are called prime and compound propositions. So again, a prime proposition. This would be something singular, simple. So it's a simple statement. Complete thought. And that's a proposition again. So that means it can be assigned a true or a false. So again, there's simple things like the sun is shining, I ran to work, Socrates is a man. Then we have compound propositions. And these are made up of two or more propositions. Okay. So, for instance, let's see. The sun is shining. So again, this would be, oh, maybe I should label this as an example. So the sun is shining, this is a prime. Okay. I ran to the computer to teach, right? And I'll even be a little bit, just to make sure that, because you could be like, who's I? Well, okay, it's me. And by that I mean, okay, so I ran to the computer. Okay. And I can combine these together. So the sun is shining. And let me find a different color pen. And I ran to the computer. So I have two prime propositions, and I form them together, and this becomes a compound proposition. So that'll lead us to what we'll cover in tomorrow's lecture, which is we connect prime propositions together to form compounds. So we can connect prime propositions to form compound. And so these are words that we start to use to form compound propositions. So we have and, or, but, however, moreover. Those are things that we use to help put those together, but we'll talk about that in the next lecture. Those are called logical connectives. So when we define a proposition, we insist that the proposition has a truth value, and it's either true or false, but not both. So there's one example of a statement where we cannot assign a truth value, and that's a paradox. That's something that is known to the ancient Greeks. So here's a definition for it. It's a statement that apparently contradicts itself. And yet might be true. So there's a very famous paradox that was known to the ancients, and here it is. Number 4. This proposition is false. So the proposition cannot be false and true at the same time. So when we try to assign to this statement as either true or false, it leads to a contradiction. For example, if this proposition is false, then it's in fact true. Then the sentence is false, but then if this proposition is false, then it's false, then the proposition is true. So again, this is something where it looks like we could assign true or false, but upon further thought, we can't. And that's what we will call the liar paradox. The other one, yeah, so I mean, in common conversation, if you wanted to employ this, you'd be saying like, I am not a liar. And that is an example of a liar paradox. If you're not a liar, then you in fact said something that's false. But if you are a liar, then that's true. But still, like we keep going around circle and okay. So like I said, for fun and jokes, if you were in a conversation, you could say, I am a liar, or I am not a liar. That would be another kind of example of that. The other one I could think of that comes to mind, not that I thought of this, but this is called the Pinocchio paradox. And that's the you know, it's a children's story, Adventures of Pinocchio, and he's a wooden puppet that dreams of one day becoming a real boy, and he's made out of wood, and every time he lies, his nose grows. So, Pinocchio then says, the paradox becomes, my nose is growing. So, Pinocchio's nose grows if and only if what he says is false. And by saying this, his nose is growing if and only if it's not growing. Then, we're getting stuck again. It looks like we could, but we can't. Okay. Is everyone doing okay with this so far that we've talked about? Okay, perfect. So far, so good. So that means what I can do is just do a couple examples. Here we go. This is from the textbook. All right. So when we look at this, which of the following are propositions? We have Napoleon Bonaparte lost the Battle of Waterloo in 18th of June, 1815. So, is this a proposition? Yes. This is quite specific. And again, I can assign a true or false. Besides, for the history majors in the room, was the Battle of Waterloo lost by Bonaparte in June 1815? I can almost hear the Googling going on. Can someone tell me if that's true or not? Yes. Okay, good. Date sounds familiar. Okay, good. We have Beethoven. Excellent. Beethoven called his third symphony Eroica. Again, this is... Yes, it's a proposition. Again, we can decide if this is true or not. All we would have to do is just look up to see if this is his third symphony, and that's what he called it. And I believe that's true. Then we have who won the football game, and like this would be like, no, it's a question. I can't say true or false to this. I can say yes or no, but it's not a proposition. So it's a question. Someone says stop. Stop. That was my terrible stop sign. And no, that's not a proposition. It's saying it's like an order, an exclamatory statement. It's not a proposition. Again, I can't sign a true or false to this. I can decide if 5 is less than 10, so yes, that's a proposition. Again, I can assign again. We'll always have Paris. Mexico is located in South America. Okay, so for this, I don't know who's we, so no. Mexico is located in South America. Yes, it's a proposition. And no, it's not. It's in North America, so. So again, this is just kind of illustrating the fact that you can have false propositions. Lock the door before you leave for the day. This is definitely not a proposition. Okay, well, maybe the you part might be a little bit undecidable, but also this is much more of a lock the door. It's more of a command. And the Toronto Maple Leafs won the next Stanley Cup. Yes, the statement is an imperative. What do you think? Always false. The Toronto Maple Leafs won the next Stanley Cup. Well, unfortunately, without getting too far into whether or not they won the next Stanley Cup, this is something that we can't decide. We can't. No, it's not a proposition. I can't tell you with certainty if it's true or false. Okay, I'm going to say this. We cannot, with absolute certainty. There's some probability, right? But we cannot with absolute certainty say if that's true or false. Which of the following propositions, 2015, Barack Obama was President of the United States. Yes. 5 is an even number, or 17 is an even number. That's also a proposition. What time is it? No, this is not. It's a question. It is raining right now and I'm wet. You might... Let's say this is me. If that's the case, if it's talking about me, then okay. Is it raining? No. Come to class? No. So it says identify the prime propositions in the previous exercise. And we can do that. Let's see if this highlighter works. So identify the prime propositions. Oh, maybe I'll just... So what I can tell you is this is one complete idea. So A. 5 is an even or... Well, these are two complete ideas connected with an or. So that's a compound proposition. What time is it? Nope. It is raining now, and so again, assuming that I know who this I'm is. So I'll put that little caveat. Assuming I know who, well, the I is. Then D and not E and F. Okay. And last, well, we're almost done this whole section here. Is Plato's proposition, I know one thing that I know nothing, a paradox? Yes, it is a paradox. I know one thing that I know nothing. And again, try to assign a true or false, and we'll start to spin our wheels. We'll get stuck. And I guess, as we finish up, we have one last minute. Just for you, then. Can you come up with your own version of the liar's paradox? In the next lecture, we'll be covering section 1.3 on connectives, and we'll be making more compound propositions and deciding if something is true or false. If there's any questions, feel free to send me an email at my email address, and I will see you all for next lecture. Thank you, everyone, and have a great day.